In this video, I want to take a look at configuring the Cogent DataHub tunneler. Before we get too ahead of ourselves, let's talk a little bit about what makes up a tunnel. A tunnel is made up of two or more DataHub nodes that can quickly and easily share data between hosts and across networks. In this very basic example, we are dealing with two such nodes, one that is configured as the tunnel master and the other that is configured as the tunnel slave. When these two nodes begin communicating, the tunnel slave establishes a TCP connection to the tunnel master. With a DataHub, this connection can be plain text as well as secured using transport layer security. Once a connection is established, the tunnel master begins pushing data to the tunnel slave. This process is called mirroring because the data in the tunnel master is mirrored to the tunnel slave at near real-time speeds. When we add in our OPC connections, we can see that the connections between each DataHub node and the respective OPC client or OPC server is local and does not need to be made across the network. It's important to note that the DataHub at either end of the tunnel can be sourcing and serving the data from any data source to which the DataHub can be connected. We're not limited to only OPC DA connections. In many cases, the DataHub is tunneling data from many data sources simultaneously. Now, with basic theory out of the way, let's take a look. What I have here are two virtual machines that will make up the two nodes on our tunnel. Tunnel endpoint 1 is running server 2008R2 and will act as our OPC client machine, and tunnel endpoint 2 is running server 2019 and will act as our OPC server machine. As you can see, not only are these two machines running different operating systems, but our tunnel endpoint 2 is in a workgroup, so has not been added to our office domain, where tunnel endpoint 1 is on our office domain. Traditionally, making a connection from an OPC DA client running on one machine to an OPC DA server running on a different machine is difficult, a problem that's compounded even further by one machine being on a domain and the other in a workgroup. Using our OPC quick line here, I will try to make a connection to the top server running on the tunnel endpoint 2 machine. As you can see, not only did this connection fail with a very classic DCOM error, it took a while. It took a while for that connection attempt to fail. So, let's try tunneling. On our tunnel endpoint 2, which is the machine running our OPC DA server, let's set up our tunnel master first. If you recall, the tunnel master will be the side that is passive in the connection, but will push the data to the tunnel slave node. On this side, we really just need to configure the connection to the OPC DA server. On the OPC DA tab, I will add a new OPC DA client connection to our local top server. The connection name I will keep at the default. It's a local connection, and I can browse through a Toolbox OPC power server. The data domain is where I want the data from this top server connection to be put. We'll call this master node for now. The rest of these settings I will leave at their defaults. Let's hit apply. And we can see that the server status has switched to running. At this point, we should be able to monitor all the data from this top server instance within that master node domain. We can see I have a few production lines set up with a few ovens. And we can see not only do we have data, but we have very rapidly changing data. Let's see if we can get this data to appear on our tunnel slave side. The IP address of tunnel endpoint 2 is 192.168.111.87. And if we look at the tunnel mirror tab here, we want to make note of the two ports listed, one for plain text connections and one for secure connections. On our tunnel slave side, on tunnel endpoint 1, we will need to configure the DataHub as the tunnel slave. On the tunnel mirror tab, we will want to add a new master connection. Not only do we need to know the host of the tunnel master, which can be IP address or host name, but we'll need to know the port over which we want to connect. In this case, I will be making plain text connection, so the default port 4502 is fine. The only other piece is we need to know the local data domain and the remote data domain. The remote data domain is the domain on the tunnel master side where the data is currently located that we want access to. If you recall, this we named master node. The local data domain is where do we want to put the data on the local DataHub node as it's being pushed from the master node. We'll call this slave node. Let's apply these changes and we can see the tunnel immediately sprang to running. Let's take a look at the view data window on this side. As you can see, just from an initial glance, the slave node data domain looks almost identical to the master node. Let's take a look at how quickly the data is updating over here. So we can see even here the data is updating at near real-time speeds. The only thing left to do now is to make sure that the quick client can get at the data as well. Rather than pointing the quick client to the remote top server that we tried to do earlier and failed, now we just need to connect it to the DataHub running on the local machine. Let's do that. Already you can see that the connection succeeded and I was successfully able to add an OPC group. Let's add some items. We can browse our Cogent DataHub namespace and we can see the slave node domain that we created in our tunnel configuration. If we expand out, we can see the same production lines that we have access to on the tunnel master side. If we expand down, we can add several of these tags. And they're successfully updating. The rate here is much slower. That is because the quick line is only subscribed at a 1-second update rate. If we decrease this, we can see a much faster update rate here as well. What we just looked at was a single tunnel slave connecting to a single tunnel master. In the real world, these systems can be infinitely complex. A very common scenario we run into is the aggregator, or a spoken wheel configuration, where we have a single tunnel slave connecting to multiple tunnel masters. The single tunnel slave is aggregating data from all these different tunnel masters and all these different OPC servers or data sources in a single point where it can then be consumed. Alternatively, we can have the flip side, where we have a single tunnel master that is serving data to multiple tunnel slaves. The benefit here is that the tunnel master makes a single connection to the data source. This means that even though the data is being served to multiple slaves and multiple consumers, the database or the OPC DA server is only being hit with a single request by a single master.
In this portion of the video, I'm going to show you a more advanced configuration where we have a plant floor machine shown here on the right where we need to get data to the business side of the network, but we do not want to have any inbound firewall ports open to the plant floor. On the left side, we have a business side machine that needs the data. Now in this scenario, we are going to have an open port on the business side to allow it to receive the connection from the plant floor. There are more advanced configurations involving proxies and DMZ where we can actually have no inbound firewall ports open on either machine, business or plant. So let's take a look at the plant floor side first. Looking at the plant floor side over here, you'll see I have the firewall up, filtered to only show the enabled, move this over here, only show enabled rules. And on the inbound side, you see the only rules I have open are my remote desktop connections into these machines, into this machine, excuse me. So here on the DataHub, I have a connection to a local top server that is collecting some data and putting it in a domain or data bucket, as we call it, called local OPC source. You see some rapidly changing data. So going back to the DataHub, what I do is I'm going to configure a connection to this remote machine. And on this remote machine, at this point, I'm not doing any SSL or username or password, though of course we highly recommend that. And in this case, I have this connection set up as write only. And what we're going to do is we're going to send data to the master, but not receive anything. So this business side, it cannot send anything back to us. We are in control of this on the plant floor. We're going to override the business side's machine with the values from here. And so we're just going to sit there and pump data over to that machine. So that connection is up and running and active, as you see here. So let's go to the business side of the machine. Now here I do have an open port for the DataHub to receive the data on, because that's the configuration we're doing here. But that's it, other than my remote desktop connection into this remote machine. So, and you see here, I'm receiving data in this data bucket called remote data that I'm sending it to from this plant side machine. And the only configuration I had to do on the business side was to tell it to accept connections on this port and have the firewall port open. And as I said, that data automatically appears here. If you did want to make this bidirectional, you would go over to the plant floor and you would change this to a read-write connection, which is what I had it in before I started this for this video. So if you want to learn more about advanced connections, open up the DataHub help file and you'll see that this is a scenario that I was doing. An OPC server sending data up to this is the scenario that I was doing right here. And then it shows you the settings on each side. If you wanted to send data bidirectionally, then you just change that data flow direction. Here's a scenario with both firewalls closed using a DMZ and the configuration that you would set up as read-only and read-write. So I encourage you to, if this is something you want to try, download the DataHub free trial and again, refer to these instructions. And if you have any questions, get in touch with us.
For videos, documentation, or to try a free demo, please visit our DataHub website.